Hello, I hope you all had a pleasant day if you're watching in the evening, or a pleasant evening if you're watching early in the morning the previous night. You're all fresh and ready to listen to the next bit of maths. My name is Sosale Mohana. I'm a maths teacher and I have taught A level maths for a long time. So, what I'm doing is just going over some of the topics, or not of pure maths for A level syllabus of UK, but useful in other systems as well. Last time I talked of, we just went over in the last couple of lessons modulus function, how to draw sketch, how to solve equations, how to solve inequalities. There are two transformations. Remember, a number of lessons ago, I discussed the various transformations of f of x, like translation f of x plus a, f of x plus a, and then f of kx, k f of x, and then f of minus x minus f of x. Now we go a bit further to think of two more transformations. So therefore, sketching y equal to f of modulus f of x using the graph of y equal to f of x. Sketching the graph of y equal to modulus f of x using the graph of y equal to f of x. Look, suppose I have, let's take an example. Sketch y equal to x squared minus 4x plus 3, and hence sketch y equal to modulus of x squared minus 4x plus 3. I'm taking a very simple example to illustrate the point. Without going into all the details, because you people are clever, you equate it to 0, y equal to 0, x is 1 and 3. No, yeah, 1 and 3, and then x equal to 0, y is 3, and then by completing the squares, it is x minus, I can write this as x squared minus 4x plus 4 minus 4 plus 3, which is x minus 2 whole squared minus 1. So at x equal to 2, y equal to minus 1 is a minimum point. So I have drawn the graph of that. Remember, whenever you draw a sketch, you should be able to give all the important information about that particular curve. By now you have enough practice how to do this. Otherwise, if you're already in year 13, you could do differentiation. 2x minus 4 equal to 0, x equal to 2. When x is 2, y is minus 1, and d squared over dx squared is plus 2, positive, therefore minimum. So the minimum point is 2 minus 1. You could do it that way as well, which for those who are in year 12 or who haven't yet done differentiation, I'll teach you maybe in another 45 lessons later. Okay, only 45 lessons later. Right. So I know the graph of that. What do you mean by modulus of f of x? Means when you put the values of x and get the values of y, consider the modulus of those values. Look, for this region of the graph, the x squared minus 4x plus 3 is positive. So modulus of x squared minus 4x plus 3 will also be positive. So this bit of the graph does not change. The red one is y equal to modulus f of x. Similarly, for any value of x more than 3, that is positive, so that will be positive. So the graphs remain the same. Only difference is between 1 and 3, y equal to x squared minus 4x plus 3 is negative. But every negative value becomes a positive value, meaning you reflect it. So in other words, instead of 2 minus 1, you have a 0.21. That the red bit is a graph of y equal to modulus f of x. So meaning, so what you do is, to sketch, again you don't have to write the notes, it's there. To sketch y equal to mod of f of x, what you do is retain the part of f of x above x-axis as it is. That's one. Two, reflect the part of y equal to f of x that is below x-axis. Here should be f of x on or above x-axis. Below x-axis in x-axis. So that is how you sketch modulus of f of x. I'll take another example. I'll leave the notes there. So let's say you've been given the given sketch represents y equal to f of x. Of course, I don't want to write passing through this, has a maximum there, has a minimum there, this has an asymptote, everything. Sketch on a separate diagram y equal to modulus f of x. So the original sketch is given to you. Let me put it like this. Very interesting. Should I? I'm going to make it more complicated. I don't know. Should I do it? Okay. So let's say this is minus 2, 0. This is 1, minus 4. This is 3, 0. That is 5, 0. That is 6, minus 2. That is 8, 0. I am making up my own question. You have to draw a separate diagram, but I'll show you on this using green. This above x-axis remains the same. Above x-axis remains the same. Now this bit 1 minus 4 becomes 1, 4. So reflect that bit in x-axis. This is negative, so it goes up to 6, 2. 8, 0. And look, it's a tangent, so it's a tangent going up, so down, so goes up. So the green bit is modulus f of x. Whatever is above the x-axis, this bit was above the x-axis, that bit was above the x-axis, keep it. Whatever is below the x-axis, flip it up. That's all. And you have to indicate the coordinates of all the points that are given, the images of those points. Understood? Okay. Now I will take up another example, another transformation rather, sketching the graph of course, again, all these things will be in the notes, so you don't have to copy any of these things. Sketching the graph of y equal to f modulus x using the graph. In other words, for example, let's understand the logic. Suppose I had a graph like this. Yeah. Let's say this is minus 4. That is, let me bring it down. This is minus 2. That is 0. And that is, but whatever it is, I'm not bothered about this. This is 1 minus 5. And then that is 4. I'm just taking a trivial example just to show you. Listen, it's f of mod x. As long as x is positive, the values of y are not affected. Y is not modulus, x is modulus. So therefore, this graph from here is not affected. Whereas, suppose you put, for example, when x is minus 2, f of minus 2 is 0. What is f of modulus minus 2? F of modulus minus 2 is f of 2. So meaning at minus 2, what was f of 2? Let's say this is 2. This was f of 2, so at minus 2 it will be there. And when x is minus 1, what is f modulus minus 1? Is f of 1, which is minus 5. So at minus 1, it's minus 5. This should have been, doesn't matter. So let's put that minus 1 there, doesn't matter, minus 1, minus 5. So what you do is, you draw the graph like this. Meaning, the negative part, because x can never be negative, this part of the graph cannot exist. But whatever was the answer on the right becomes answer on the left. So therefore, I hope you understand, but it's pretty straightforward. If you come to think over as to what I said, that means x can never be negative. So the original graph, whatever that was there for negative parts, cannot exist because x can never be negative. So the negative part is gone. And whatever was the positive part, for x equal to minus x equal to 2, y was 4. X equal to minus 2 makes it modulus of minus 2 is 2, y will still be 4. That's why, very simple. So the rules will be, retain the graph of y equal to f of x, that is for x greater than or equal to 0 in, as it is rather. Delete the graph of y equal to f of x for x less than 0. Then add instead the reflection of, let's call this as number 1. Reflection of number 1 in y-axis. So let me just take one example. The sketch shows the graph of y equal to f of x. Draw or use this to sketch the graph of y equal to minus x. Oh, sorry, f modulus x. So you've been given this graph. Let's say something like that. So this point is 0, 3. This point is minus 2, minus 1, 0. This point is minus 8, 0. And this is the line x equal to 0. That's f of x. So what you do is, the part to the right, keep it as it is. So that bit remains the same. In the exam, please draw a separate diagram, because you might draw over the previous one. The examiner doesn't know which one you're talking of. Because even if you color it, these days I understand they photocopy the paper, so the color doesn't come through. So you might lose marks. So always draw separate diagram. Don't use the same diagram. And then this bit, ignore it. So I've ignored it, and then reflect there. So that graph goes like that. So in other words, I can draw the graph here. It's a graph like that. And, oh sorry, it's a graph. Oops. It's a graph like that. So it's a graph like that. This is f of modulus x. Well, that finishes modulus functions. Later on, I'll have to now decide whether I should continue with algebra. Anyway, from the title of the next lesson, you will know. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.